we are going to see is how to convert one number system to another number system. So we have seen 4 types of number systems, right? So we have seen for binary, octal, decimal, and hexadecimal. So we have seen these 4 types of number systems. So what we are going to see is we are going to convert one number system to another system. That means these binary number system can be converted into 3. So one is with decimal, octal, and hexadecimal. And again, this octal also converted into 3. So one is with binary, octal, sorry, decimal, and hexadecimal. As the same way, this decimal number also converted into 3. So one is binary, octal, and hexadecimal. And the same way, this hexadecimal also converted into 3 types. So one is with binary, octal, and hexadecimal. Totally, how many conversions we'll get here? 12 conversions we'll get. So we'll see how to convert from one number system to another number system in today's class. Okay. The first conversions what we have is decimal to any another number system. That means decimal to binary or octal or hexadecimal. So how we are going to follow these kinds, how we are going to design or how we are going to convert decimal number system to remaining other number systems, we'll see the first. The first, okay, tell me not these. So every time we are solving this only. So we'll take the new value. We'll take the new value. So give me any decimal number. Give me any decimal. The numbers should be there in between 0 to 9. Decimal numbers can be represented in between each digit. Not say I'm saying here. Each digit can be represented only from 0 to 9. So tell me now. Tell me any decimal number. 48. Huh? 48. Two digits is enough for you. Okay. So this is my decimal number. So I want to convert this decimal number in form of binaries and in form of octals and in form of hexadecimals. I want to do these 3 conversions. So first we'll go for decimal to binary conversion. So decimal to binary conversion. So my number is 48 of my decimal. So I want to convert it in form of binaries. So first what we are going to do is, so I have a 48. So I'm going to divide this weight. I'm going to divide this number in the numbers, in the opposite conversion what I want. So I want to conversion in form of binaries, right? So I'm going to divide this with 2. So how many times it will go? 24. And what was the remainder of it is? 0. Remainder of this. So if we multiply 2 with 24, you will get remainder as 0. So we are going to write number of times here and remainder at beside it. So again we are going to do that. Again I have a chance to multiply divide it. So how many times it is going to be divided? 12 times, and the remainder of it is 0. Again 2. So how many times it will go? 6 times, and the remainder of it is 0. And again how many times it will go? 3 times, remainder is 0. And again 1 time, remainder is 1. So this is the number what I got here. So I want to write the number. So how I am going to write my binary number? So I need to write in form of zeros and ones. If I have a binary number, it should be there in form of zeros and ones. So if you see here, we got our reminders or the last one as in form of zeros and ones only. So what I'm going to do is I'm going to collect from bottom to up order. So what was the bottom number we have here? 1. And after that 1, 0, 0, 0, 0. So we are going to collect in an order. So how we are going to collect here? 1, 1, 0, 4 zeros. 0, 0, 0. This was the number what we got. So I want to know whether it is working, the thing what we have written correct or not. How I am going to do that? So multiply with weights. If you multiply these weights, if you got the exact number what we have here, then we can say the operation or the conversion what we have did is correct. So multiply the weights. So what was the weight of this? 1. And for this it is 2, and for it is 4, and for it is 8. It is 16, and this is 32. Okay, multiply with weights. So if you do 0 into anything is 0, 0 into anything 0, 0, 0. At here only we'll add. So 1 into 16, 16, and 1 into 32, 32. 16 plus 32, 48. So we have the decimal number is 48, and we got the 48. Then it is correct. So this is rechecking of your conversion. So the conversion what we have did is correct or not. So if you want to find it is correct or not. So we are going to do this. Just if you want to make conversion, this number is enough for you. So you want to check it, you want to verify it whether the conversions what you have did correct or not. We are going to cross check it with multiplying with weights. Okay, so the next conversion. So previously we have converted decimal to binary, right? So now we'll convert the same thing with the decimal points. So the same thing, 48.12 is my number. So I want to convert this decimal number in form of binaries only. So how I am going to do that? So we know how to do this, right? We know how to do 48. So how we are going to do? We are going to divide that number with the base what we need, the opposite base what we need. So here I have a decimal point, 0.12. So I want to convert it in form of binaries. So how I am going to do that is 0.12 multiplied with your base what we have. So if you have a base 2, you are going to multiply with base 2. If you have a base 8, you are going to multiply with base 8. So 0.12 into 2, how much it is? 0.24. 0.24 into 2. So how much it is? 0.48. 0.48 into 2. 0.96. 0.96 into 2. 1.92. This is the one. So here, how many times I need to multiply my value? So still my decimal, so the point after the decimal should be changed until my point before the decimal is getting changed. That many times I need to multiply my value. So here previously I have 0. Usually if you take any value also it will be 0 only. So rather than 0, if you got some other value, there itself you can stop there. Okay. So now the value is changed from 0 to 1. So I can stop here and I need to write my value in from up to down. From up to down, I need to represent my value. That means 0.0001. And what was the 48 we got here? 110000. So this is how we are going to represent 48.12 of your decimal number in form of binaries. Okay. So point after the decimal, we need to multiply. Point before the decimal, we need to divide. This is what we need to. From point before the decimal, what we are going to do? We are going to collect the data from bottom to up. From point after the decimal, what we are going to do? We are going to collect the information, or we are going to select the lines or numbers from up to down. This is what. The next one is the next conversion. So decimal to octal conversion. Decimal to octal conversion. So now tell me any decimal number. Tell me any decimal.
29.
Hmm?
29.
999. So this is your decimal number. So you want to convert this in form of octals. That means base 8. So how we are going to do this? 999 is going to be divided with 8. So divide it with 8. So how many times it will go? 124. What was the remainder? Remainder is 3. Is correct? 124. 124 into 8, how much? 992. Okay, if it is 992, the remainder is 7. The remainder will be 7. So again, there is a possibility to divide your number. So how many times it will go? Hmm? 50. 15. Okay, the remainder is 4. Remainder is 4. And again it have a possibility to divide by number. So one time and the remainder is 7. So you got 1747 as your triple line. So 1747 is a representation of your octal number. So for the respect to decimal number. So 1747. So here 1747 we are going to collect from bottom to up. So my bottom value is 1, next is 7, next is 4, and next is 7. So this was the way to represent your decimal to octal. So if we have same 999.14, this is your decimal number. So how we are going to convert it in form of octals? So 0.4 into 8. Here I have an opposite radix of 8. So I want to multiply this point after the decimal. So I need to multiply with 8 here. So multiply that. 0.14 into 8. How much it is? 2, 3, 1.12. So here itself my value has been changed. So I can stop here. I can take 1 as my decimal number. So here 1747.1 is my representation of 111.14 in form of octals. Okay. So if you have some other value, you need to do that. So that's it, but you need to follow the same process here. So if you have another value as your decimal number, and if you want to convert it to the respective radix, you need to follow the same procedure. So the next conversions what we have is decimal to hexadecimal conversion. So tell me any decimal number, another decimal number. 1240. So this is my decimal number. So I want to convert it into a form of hexadecimals. So how we are going to do that? So 1240 divided by 16. So how many times it will go? 70. 77. And what was the remainder? 8. And again 16. How many times it will go?
4 times.
4 times. And remainder? 13. And next one is? So that's 6. So 4 and 13 is going to, if you want to represent 13 in form of hexadecimal numbers, how we are going to do? We are going to represent with an alphabet D. So whether it can be a small letter or a big letter. So we can represent with both. So next one is 8. 8 is going to represent as an 8 only. So 4D, 8.